Hello, my name is Justin Castillo, and this is my final project. So for this, I did a binary classification project to predict whether a student would pass or fail a class based on demographics, on past academic achievement, and on course engagement, which was measured by a number of clicks the student had on this on the online course. This is from the Open University uh, um, learning analytics data set. Open University is a large online university in Europe that has over 2 million students. So predicting whether or not a student would be successful could allow us to intervene before the student fails the class. Identify at-risk students before it's too late. So I used data from three of these four tables. This contained temporal information, which I wasn't dealing with. This is the main table. It had a lot of useful features, mostly on demographics, and of course it had the target, which was final results. I simplified final result to just pass or fail. There's like distinction or withdrawn. Withdrawn, I made it to fail, and then distinction was passed. So it was simpler for the model to predict. Um, I merged them with VLE, which is basically I just got the number of clicks that each student had on the website. I aggregated that per student, and then with student assessment, we had this average score, and then I also could get the number of assessments taken, which is another measure of student engagement in the course. So I merged all of that with student info. I imputed 0 for nulls that were created by the left joins. Um, and I one hot encoded the categorical features and scaled the numeric features to make it easier for the model to get the signal from those features accurately. Um, and then I went ahead and did my baseline. So the model I used was a dense neural network. Um, just a couple layers, each with a dropout layer. Um, and these used ReLU activation functions to capture the nonlinear associations, and then the sigmoid and the output layer made that into a probability of the output, of the target feature being 0 or 1. That was used to by the model to make its final prediction. So um, that's just the baseline. I created these functions just to simplify training it, so I could do a bunch of tests quickly and get visuals for each one in a uniform way, so I could compare compare them and see what the trend was. So I tested a bunch of different models. I experimented with increasing the neurons per layer. I added a layer. I adjusted the epochs a few times. I increased dropout rates to provide regularization. I added L2 regularization as L1. If I added that, since I one hot encoded categorical variables, L1 would have resulted in a loss of signal, it would have distorted it because it would have eliminated some features that were simply indications of a class, uh, not really a feature in and of themselves. But L2 just made the model worse. Basically, everything I did just made the model slightly worse. At the end, I didn't manage to beat the baseline by a whole lot, but the model did generalize pretty well with a final accuracy of 89.79%, loss of 0.2367, just a small improvement on the baseline, but this is on an unseen test set that I verified. Um, was unseen. Basically, one of the issues I had was I went through all this and I did all my markdown, and I realized that I did not have a true holdout test set. I just used a training and a validation set, and I had to kind of delete everything and redo it all, making sure that there was no data leakage. But I ended up with pretty similar results, I guess because this is such a, you know, pretty clean data set that's well suited for modeling. There's, all the size of the data set is right, for this type of model. So, there wasn't a whole lot of improvement, a whole lot of room to improve, but it did generalize pretty well. Thing I would do differently is I would probably not do my experiments. I kind of did them in a little haphazard manner. Um, I wanted to make sure I respected how the hyperparameters would affect each other and not just the final result. But I would probably use like grid search or some sort of more systematic way of testing uh, values for each hyperparameter. I kind of did that with the dropout rate, but yeah, it's just because I got tired of scrolling here, so I did a um, uh, yeah. Well, I think that concludes my presentation. Thank you very much for watching.